All right, so we're combining lesson 5 and lesson 6 here. I apologize for the odd arrangement here, but having troubles with the files here. So here's what we got going on here. The idea is we saw where we're finding area by counting spaces. Now, what's going to happen though is the grid's going to disappear, but we're still going to be using the grid. So the basics here, we want to know how long is it for line segment MO. So to get from M to O, remember you're starting here, but then you are counting. So that's a 1, a 2, a 3, a 4, a 5, and then a 6. So MO ends up being from there to there ends up being a 6. Go across for MN, a 1, a 2, a 3, a 4, a 5, a 6, a 7, and 8. It goes across 8. So it's a rectangle, 6 times 8. Yeah, that's where your 48 units end up coming from. So again, we're just kind of counting along with it. Not a big deal. Triangle, more of the same. You're going to do your base and your height. So you need to figure out FG, figure out FE. So again, if we're counting FG, a 1, a 2, a 3, a 4, a 5, a 6, a 7, 8. So it does take us 8 to go there. How far up is it? Because again, that's our right angle, our base, and our height. A 1, a 2, a 3, a 4, a 5, a 6, a 7. So we multiply base times height and divide it by 2. 7 times 8 is 56. Half of 56 is 28. So again, there's the ones that we've been kind of seeing here. Again, more of your rectangles here. Now, what we want to try to do though is get away from just simply counting. So what we're going to try to use here is the grid. But what we want to notice is we always count from the axis that we are looking at. So for example, if we want to find the area of the rectangle in question number 2 that's there, one of the things that we need to do is figure, okay, there's right angle. So I need length and width. So I'm going to use from I to H, and then I'm going to use from I to J. But instead of just simply counting, we want you to notice some things here. So on your particular axis that you're looking at, if there's your eye, and this is why we kind of got it written off to the side like this so we can do this extra kind of drawing there. We want to know, and there's my poorly drawn rectangle, but still a rectangle there. We're always going to count from the axis. So if we notice here, to get from the axis out, see how it goes through the 4? So that means from here to here, it's 4 units. And then do we see to get out to H, it goes through the -6. So the actual distance, and that's why we talk about our good friend absolute value. Oh my goodness, absolute value. Definition. Come on, say it. Absolute value. That is the distance from 0 on a number line. Yes. Oh my goodness. I thought she would have that right. So yeah, it's a 6. So the entire distance all the way across is a 10. Now again, if we wanted to count a 1, a 2, a 3, a 4, a 5, a 6, a 7, 8, 9, 10. Again, we're trying to get away from it because we're not always going to have the grid to count on. So let's see if we can do the other one, going from I to J. How far are we away? Well, we're only 1 away. Okay, because again, we only went up the 1 that's there. I know I got a poorly drawn sketch that's here. So from there to there, we're saying it's a 1. From here to here, again, we went all the way down to -8. So again, the distance, though, the absolute value is an 8, so the entire distance is a 9. So the area, 10 times 9, hello, 90. So again, distance from the axis, because then we can use the numbers that are on the particular graph that we are looking at. So let's skip all the way down, and like I said, you see we got binaries. There's 4, technically that would be 5 there. So okay, so let's take care of this guy here, and again, you can write directly on it. I'm going to kind of sketch it a little bit, see if I can do a little better job with my XY axis, maybe a little bit. Okay, so I need Basin Heights. So I need to know how far it is from here all the way to there, and from there all the way to there, because that's where my right angle symbol's at. So if we notice from the axis, we go up how far? Yeah, you can see there it is. There's the 8. So we went up 8, and we went down how far? Yep, there's the -2. So we went down 2. So the entire distance is 10. Yeah, so all that's a 10. How far to the left did we go? Well, we went -3, so that means it's actually a 3, because again, it's the distance. And here I went all the way over to the 5. All right. So if I went 3 that way, I went 5 that way. Altogether, I went, 8. So now we can solve it. Base times height divided by 2. And that's where your 40 comes from. All right. So, and much you may think it is, let's just count on. All right. Well, here we go. This is the stuff we want to make sure that we can end up doing on it, because these are the problems where we're not going to have that XY axis to work off of. And to count, actually, we have the XY axis. What we don't have is the grids to count the dots. So let's look at the first one we've got right up there. Okay. What we want to see is, again, how far away we are. Now, the issue here is, they didn't give me the grid here. So 1, I could fill that in if I wanted to. All right. 2, let's kind of think this out here a little bit. If we think about our XY axis, okay, which axis is this? This is the X axis. So if I want to know how far it is from here to there, all I'm going to look at is the X coordinates. Well, remember, the first one's always X, the second one's always a Y. So here we go. We're going to use the first numbers. We're going to use the first numbers here. So from -9, the ordered pair -9, -10, and then we're trying to get to the ordered pair -3, -10. We're only going to use the X one. So the first one's always the X's. So how far is it from a 9 to a 3? Remember, it's absolute value again, so it is positive. How far from 3 to a 9? It's a 6. There we go. So in our rectangle there, we know the distance from here to here is a 6. So again, if I sketch my rectangle, that would be a 6 there. Now, up and down. Up and down uses which axis? It uses the Y-axis. So when I go up and down, I look at those ordered pairs. I got the ordered pair -9, 8, and I got the ordered pair -9, -10. So I only want to use the up and down, so the Y's. I want to use the 8s, and I only want to use the -10. So how far is -10 from the axis? Well, it's 10 away. How far is 8 away from the axis? Well, it's 8 away. So altogether, you are 18. All right. So we don't need to kind of formalize it. And again, you can write right on there, hey, this should be a 10. That's there. I went up 8, and again, because we went up and down are your Y-axis that you are looking at. So let's take a peek at question number 2. All right. First of all, the information that we need is the base and the height of that particular triangle. So as I'm kind of looking at it, I'm looking at this, I'm looking at this, I'm looking at this. I see the 3, 4, I see the 10, -7, and I see the -3, -7. So okay, so if I want to figure out how far it is from here to here, X or Y axis, that's the Y axis. So I'm using a 4 and I'm using a -7. Yeah, because again, the Y, remember, it's always X and then Y. Alphabetical order. My goodness, math making sense here, actually. Alphabetical order. Okay, so how far is 4 away? And again, if you look at your axis, it goes right through there. How far is 4 away? Well, it's 4 away. How far is -7 away? It's 7 away. So how far are you all together? You are 11. Yeah, there's my right angle symbol. So again, when we look here, all right, my axis is going to be over there. I'm now going left to right. Left to right is your x-axis. So this time I'm going to use the x coordinates, which are the first ones. So, oh, did I copy it? Yeah, that's not a -3, is it? My goodness. How come you didn't say something earlier? All right. So, yeah, that's just a 3. So, how far is, wait. Okay, distance, wait a second. So here's one of the things we want you to notice. When you cross over an axis, you're always going to add, because from here to here is 4, from here to here is 7. Now, we're not crossing over an axis, so we're at +3 trying to get to +10. How far is it from 3 to 10? Yeah, it's 7, exactly. So, and again, you can just do 10 minus 3 to get to your 7 that's there. So 11 times 7 is 77. We got to chop 77 in half. All right, so if you want to do a little division off to the side, no big deal. We can do that. 2 into 17, 8 times? Yeah, 16. My goodness, am I kind of making things a mess here. 38 and a half. So there's our answer. So something important kind of happened there. If you have to cross an axis, you will always add. If you don't have to cross an axis, then you don't have to end up adding them together. So a lot of generalities. Again, we're working with your visuals that are here. It's something where you might be a very visual learner, so you're going to use them. And some of you are like, I need more structure, Mr. Savage. You got to tell me exactly what to do, when to do it, and then I can handle it. Okay, so what we're going to do is we're going to do one more. We're actually going to drop over to question number 4. That's here. Okay. So when we look at our particular rectangle that we've got, we're going to try to stay away from doing too much here. So I got the order pair 2, 6, 7, 6, all right, 7, -4, and then 2, -4. The only axis I'm dealing with is right there, okay? So I need length and width here. So I'm going to go with this particular line and with this particular line. So first of all, the one that's going from left to right. Left to right, which axis is that? That is my, that's my x-axis. So I'm using the 2 and I'm using to 7. Am I crossing over an axis? No. So how far is it from 2 to 7? Well, it's 5. All right. And again, you can do the subtraction problem. Did not cross over. You will subtract. Now here, I'm trying to go up and down. Up and down is which axis? It's the y-axis. So I've got a 6 that's here, and I've got a -4 that's here. Remember, your y-axis is always, the y-coordinate is always the second one that you've got. So, it's a -4. Okay, so how far is -4 to 0? Well, absolute value, it's 4. How far is 0 from the 6? It's 6. So we will add to find the total distance. So we get 10. All the way. So 10 times 5, there is your 50. All right. So again, we're working a lot more on the actual ordered pairs rather than just simply counting the dots all together. All right. That's all that we have, folks. All right. We'll practice this more in class.